Yes, Zainab.
Moment is a turning effect of a force around a pivot.
Very good. Very good. So what
Mo-
do you understand by that?
that moment is the product of force and distance on a specific point.
Right. So basically, moment of a force means the turning effect of a force. Like you see, force can cause a lot of changes, right? It can cause displacement. Displacement is what? Displacement is the change in position. But one of the effects of force is also to turn something. Now, turning can happen only, for example, if we're talking about a rod or any object which is more than a point, okay, which is what do I mean by that? Like, for example, if I apply force this way, can you see that the pen tilted, right? The pen tilted. Why? Because this point was fixed somehow, this point was fixed, and the rest of it moved. So when you have a big object meaning like, like I'm not talking about one point. I'm talking about a lot of points. Usually objects are a combination of a lot of points, right? One point will be fixed. The others will be allowed to move, okay? If, for example, the whole pen is moving at the same, at the same rate, then there will be no turning. In fact, the whole pen will move up. That's all. Okay, only its position will change. So there was no turning effect. But if one point is fixed and the force acts on the rest of it, then that's when you have the turning effect. So this fixed point is called the pivot. This fixed point that is not allowed to move is called a pivot or a fulcrum. It's also called a fulcrum, same thing. And remember that, and remember the turning effect of a force is always about this pivot. What do I mean by about this pivot? Meaning that, as Zainab just mentioned, that the turning effect of a force is the product of the force, the magnitude of the force, and the perpendicular distance between that force and the pivot. Okay, between that force and the pivot. And when I say perpendicular, I underline it. I emphasize on the fact that it should be perpendicular. Sometimes in questions, they trick you. They give you distance between the force and some fixed point, which is a fulcrum, but it's not perpendicular. For example, let me draw this diagram. If you have a rod like this and it's tilted, this is the horizontal, okay? This is the horizontal, okay? And this is the pivot. For example, this point is not allowed to move and the force is being applied this way and they have given you this distance. For example, it is 8 meters, okay? Now, you will not multiply the force by 8 meters. Why? Because this is not a perpendicular. It's not perpendicular to the force. Remember, the distance should be perpendicular to the force. Sorry, the force is, sorry, not here, sorry. This is wrong. The force is, for example, applied here. Yeah. If, for example, the force is applied here, then this is not perpendicular. Perpendicular meaning making an angle of 90 degrees. This is not 90 degrees, so we will not use this. In fact, what we will try to do is that we will try to figure out this distance, because this distance is perpendicular to the line of action of force. Line of action of force. What does that mean? That first of all, in which direction is the force acting, and line of action. So when you continue that line, you get a line of action. So remember, line of action of force should be perpendicular to the distance. Okay. Another thing that is very important, I'm going to explain you the points, okay, the basic points of this chapter, and then we will directly jump on to the questions because we don't have much time and I want to do at least one worksheet that Ramin shared with us in the group. So I want to do at least one worksheet, if not both of them, and then we will see how we can do the second one. If you really want me to do, or if it's okay to leave it, we will decide that. So looking at the formula of the turning effect of a force, it is the product of force and the perpendicular distance between the force and the pivot. The unit for force is Newton, the unit for distance is meter, and so the unit for moment, because it's a product, will be Newton meter. Now, another thing is that there can be only two directions for turning, either clockwise or anti-clockwise. And I hope you understand clockwise and anti-clockwise, right? So whenever you decide, and we will discuss in a moment how we will decide, imagine a clock in front of you, and imagine a clock, okay, in your mind. And real quick, you should be able to decipher if this particular force, you will keep the pivot fixed, and you will imagine that force, and you will consider that beam as the clock hand, and you will see how is that moving. Is it moving, clockwise, or is it moving anti-clockwise? And that's how you're going to decide. So we're going to practice that a little bit. So clockwise is going to be this way. Okay, I always write 12. So it helps me in deciding. And so this is going to be anti-clockwise. So this is anti-clockwise and this is clockwise. Okay, how do we find out? Remember, they try to trick you in the questions in many ways. One of the ways is, one way I told you is this, that they will give you a distance which will not be perpendicular. And so you will have to figure out what the perpendicular distance is. This is one way of tricking in the question. Another way of tricking is that they will give you a lot of forces acting on the same beam in different directions, right? For example, this is a rod. For example, this is a rod, okay? Also, in questions, when they say uniform rod, understand this, they tell this on purpose. Uniform rod, what does it mean? It means that the mass is uniformly distributed. It is not thicker from any side or thinner from any side. Okay, it is, the mass is uniformly distributed, uniform width or thickness. Okay, this is what uniform means. Why is that important? Why is it important for them to mention that the rod is uniform? Because only if the rod is uniform will you have the center of mass exactly at the center. Center of mass exactly at the center. What is the center of mass? Have you guys done center of mass, stability, equilibrium? Because I saw questions in the worksheet. Sorry?
It's part of our exam, miss.
Okay, center of mass and all of that. Right, but it's not in the chapters that
There's a separate chapter for it, miss. It's center of mass.
which chapter number is that?
That is chapter number 11.
Oh, okay. So I haven't covered that with you guys. Okay. So center of mass. So what do you understand by center of mass? Do you know?
Center of mass is a point at which a force acts on an object.
Yes. Yes. Okay. That's the definition. Yes. So like, each and every atom or particle, I'm going to really quick tell you what center of mass is. Each and every particle or matter that is making up this meter rule has a downward acting weight, right? We all understand and appreciate that weight is a downward pull, which is directed towards the center of the earth. So all these small, think of these atoms having small weights, okay, all are directed towards the center of the earth. But it is very difficult to consider them individually. That would be a lot of hassle, especially in calculations. So what they do is that they all seem to be acting through the center of the body, through the center of the mass of that object. So we add them all up, we add all these weights up of all these small atoms, and they all seem to be acting through the center of that object through the center of mass of that object. Now, the center of mass of the object is not necessarily the center of the object as well. That is true only in case if the object is uniform, symmetrical, meaning same mass on this half and same mass on the other half. Only then you have the center of mass in the center in symmetrical objects. But if you have an asymmetrical object, then the center of mass is going to be more towards that half which is bulkier, which has more mass. For example, if something is shaped this way, now this half has more mass than this half. So the center of mass will be more towards the bulkier half of the object. You understand? So the center of mass is not going to be at the center here, but the center of mass is more going to be towards the bulkier part, somewhere here, okay? So that is why it's important for them to mention that the rod is uniform, so that you know that the weight is acting exactly at the center. And when they say meter rule, it means that the rule is 1 meter long and 1 meter is equal to 100 centimeters. And half of 100 would be 50. So that means weight would be at 50. These are, little tips and tricks that I'm telling you. Okay. So what was I saying? I forgot. Okay. So what was I saying? I totally forgot. Okay. Yes, so I was trying to explain of how to find out if the turning effect of a force is clockwise or anti-clockwise. So if, for example, this is my beam or balance or meter rule, and there are many forces acting upon it, it is hanging through 2 threads, okay? Tension in the thread is upwards, okay? And then you have one weight hanging here. Then you have another weight hanging here. For example, I'm just giving examples and so all these are acting downwards, maybe one here, okay? Let's say 70 Newton, so on and so forth. Now, if we are given some calculation, for example, let's suppose they're asking us to find the weight of the rule, for example. Now, how to go about this? Don't be confused, okay? Just choose one pivot. Choose one pivot. Now, while choosing pivot, you have to read the question and then choose accordingly. If, for example, they're asking you to find the weight, then of course you are not going to take the, you are not going to consider this as your pivot because you have to find this out. So you will make some easy point, some convenient point for yourself as the pivot, okay? For example, let's say this is A, this is B. I'm choosing A as my pivot. For example, I'm choosing this A as my pivot. Now, using the law of moment. What is the law of moment? Law of moment is that let's see, who is this other person? Yes, Abdul Wadud, yes.
The law of moment is that
Yes, I cannot hear. Okay, I cannot hear you. Okay, law of moment is that for anything to be in equilibrium, for any object to be in equilibrium, the clockwise moment is equal to the anti-clockwise moment, meaning that there is no net turning effect. There is no net moment, okay? Whatever the moments are, they're all canceled and they're equal and opposite, so the thing is not turning. That's why the thing is not turning. If there was any net turning effect, it would turn. It would tilt. Okay, so now if this A is my pivot, okay, I will keep this fixed because it is my pivot. So I will keep this fixed. Now I will consider each and every force one by one without confusing myself. And I will write down clockwise. I'm just writing CW for clockwise, anti-clockwise, ACW. Okay, ignore this. Okay, so now considering this force. What is this force doing? What is this force doing? Moving it downwards, right? Downwards. So am I going clockwise or anti-clockwise? My clock is, I will draw a clock as well here. So this is going, so if I just look at this force, if I just look at this force, what is this force doing? Taking it this way, taking it this way. So this is clockwise, right? This is my imaginary clock here. So this is going this way. So this is clockwise, okay? So I will take this, this force is causing a clockwise turning effect. So I will write this here, 50 multiplied by whatever the distance, okay? I'm just giving you an example. What is this force doing? For example, this is thread 1, this is thread 2. What is this doing here? This is moving the beam this way. This is anti-clockwise, okay? Anti-clockwise. So I will write it here, T1 into whatever the distance is, okay? And so on and so forth. What is this W doing? Moving it this way. This is clockwise. So that will come here, okay? I'm just giving you an example of how to W multiplied by. When I was a student, I used to get confused. These were really confusing questions for me as well. Now, why? Because all these other forces would confuse me. And I would say that, no, you know, maybe it's not moving it clockwise, because I would imagine this beam hanging. And so when you are considering one force, forget the other forces. Don't think that this beam is hanging. No, this beam is not hanging by these two threads while you are considering each force individually. When you are deciding their turning effects, when you are deciding whether it is clockwise or anti-clockwise, forget the other forces because they will confuse you. Okay, so let me do this whole thing. So W multiplied by its distance. Distance between your pivot and that force. Also remember that. Don't multiply with any other distance. Only the distance between that force and your pivot, whatever you have considered your pivot. Now, what is your pivot? In your calculation, you can choose your own pivot. Do you understand? And it does not matter which point you choose as your pivot, your answer will be the same as long as your calculation is correct, as you follow these rules, okay? It doesn't matter. Even if somebody takes P as his pivot, if he's doing the calculations correct, you will get the same answer, okay? So now look at this force. What is this force doing? Moving it this way. So this is clockwise again. So this will go in the clockwise section. 100 multiplied by whatever distance between 100 Newton and the pivot, whatever that is, okay, according to the question. Plus, what is this T2 doing here? Again, it is again anti-clockwise. So then T2 multiplied by the distance between T2 and the pivot, okay? So on and so forth. I hope you got the idea. Okay, so this is how you're going to decide whether a force is having a clockwise or an anti-clockwise turning effect. Now, okay, so this we have already discussed. Okay, remember this. Okay, another point, not only is that for an object to be in equilibrium, is it important that there should be no net moment acting on it, meaning that any moment or turning effect must be canceled by equal and opposite turning effect. This is about the turning effect, but then there's another condition, no net force acting upon it as well, meaning whatever force, whether it has turning effect or not, should be balanced by equal and opposite force. What do I mean by this? For example, this, again, the same beam. Now, this was the turning effect, right? The turning effects are canceling each other out. But the total upward forces is equal to the total downward forces. Okay? So forces don't have only turning effect. They have other effect as well, right? They can move as well. So that's why the meter rule is not moving anywhere. It's neither moving upwards nor moving downwards. Why? Because the total upward forces is equal to the total downward forces. So T1 plus T2 should be equal to 50 plus W plus 100 plus 70. Do you understand this? So T1, this is another condition for equilibrium, okay, that you should remember. This is also a part of the law of moments, maybe. Okay, so the total upward forces is equal to the total downward forces. So total downward forces would be, in my example, 50 Newton plus W plus 100 Newton plus 70 Newton. Okay, now keeping these rules and laws in mind, let's just start solving the questions. Okay, and then there's this levers part, lever. Now, don't be confused by this same thing. Same phenomenon is working here as well. So you have two forces. They have a turning effect about a pivot or fulcrum, okay? Effort is what you are applying. Effort is usually the force that you are applying to get something done. And load is that force which is resisting your effort, okay? So if, for example, you're using this crowbar to lift this boulder, your force that you're applying at this end will be effort, and the weight of the boulder on the bar will be the load. Okay, simple. There is nothing to explain much. It's the same thing, same phenomenon of the turning effect of force or the moment. Okay, so in the case of this wheelbarrow, the fulcrum is the center of this wheel. The effort, I mean the force with which you hold or lift the barrow is the effort, and the weight of the wheelbarrow is the load. Okay, so if they give you a diagram, for example, and they ask you to label the effort and load, how are you going to decide which one is effort and which one is load? Just see, where are you applying a force? Where are you doing a job? Wherever you have to apply a force, or wherever something has to apply a force, that will be the effort. And then you decide what force is resisting it. That will be the load. Okay, so here in this case, the work is being done here. The work is being done here, so this is the effort. This is resisting, so this is the load. Yes, Abdul Wadud?
Can the load be the weight? Sorry, the gravity?
Yeah, because gravity is acting through weight. Yes, weight is gravity. Okay, weight is due to gravity. Gravity doesn't act separately. Gravity is acting through weight. Okay. Okay, another point that I just remembered that I forgot to mention is that if you pay attention to this formula, you will also realize that if we increase the distance for the same turning effect, you need a smaller force. What do I mean? So turning effect is, moment is a force multiplied by the perpendicular distance, right? So if force is 2 Newton, for example, distance is, for example, let's suppose 8 meters, okay? And so your turning effect is 2 8 is 16 Newton meter. 16 Newton meter, right, is the turning effect. Now, if I want to decrease this force, I don't want to use this much force. For example, I want to apply only, let's suppose, 0.5 Newton. But I want the same turning effect. My distance should be how much? 32, I think. Right? Am I right or not? Yes, 32 meters. So I have to increase the distance 4 times to decrease the force. Do you understand? So if I want the force, less force, if I want to have less force, I have to increase the distance. Distance between what? Between the force
Pivots.
and the pivot. Yes, the distance between the force and the pivot, the fulcrum. Okay, now let's jump on to the questions. Have you guys done the book question? Should I skip it and start the worksheet, or should I do this?
Ma'am, I have done.
I think, Miss, we can do the worksheet questions.
Okay, you know this? Okay, just one point that I want to mention here is that because you see, we have two parts of the equations. We have two parts to an equation. And if we are using the same units on both the sides, so they will get canceled out. And so it doesn't matter what units you use, as long as you're using the same units on both sides of the equation. Are you getting me? Like, for example, they have used centimeters and grams here. Centimeters and grams here, but it doesn't matter. Why? Because they get canceled out. Okay, when you have clockwise and anti-clockwise, see, when you have clockwise and anti-clockwise, so no matter, like if you are multiplying something by 10 here, you are multiplying same thing by, 10. I mean, you're multiplying the number by 10 here as well. So this time, if you divide both the sides by 10, 10, 10 get canceled. So it doesn't really matter at the end. So same thing. So I hope you got the point. Okay. Have you done this question? Just want to double check with you. Have you guys done this question? Did you understand? Can anybody explain me real quick?
Revise. Can you revise?
Okay. Figure 10.8 shows 3 positions of the pedal on a bicycle, which has a crank 0.2 meters long. If the cyclist exerts the same vertically downward push of 25 Newton with his foot, in which case A, B, or C is the turning effect? Part 1, 5 Newton meter, meaning 25. So force is 25 in all the 3 cases. Force is 25 Newton in all the 3 cases. And the crank is the same as well. Crank is what is joining the bar, sorry, the pedal with the center of the wheel. The pedal with the center of the wheel. We increase the clarity and zoom in. Okay, I'm not using the chat window. Okay, इसको disable कर दो. Okay, if you want to say something, you can unmute yourself. You can unmute yourself and say it. That's okay. Yeah, I'm not enabling the chat. Okay. So the force, the vertical force that is being applied is 25 Newton in all the 3 cases. And the crank is also the same, joining the pedal with the center of the wheel. But then what is the difference? Okay, let's do part 1. In which picture is the turning effect 5 Newton meter? That is 25 multiplied by the whole length of the crank. Whole length of the crank is 0.2. Yes?
I have a question.
Yes?
For the first one, I don't understand the values they've given over there, like I, double I, and triple I. I don't understand what those values mean.
Like they are asking in which of these pictures is the turning effect 5 Newton meter, 0 Newton meter, or between 0 and 5 Newton meter. So you have to choose a picture for each one of these turning effects.
Oh, okay, miss. Okay.
Yes. So now tell me, which picture is showing you a turning effect of 5 Newton meter? So 5 Newton meter, how? This way, meaning force multiplied by the perpendicular distance between the line of action of force and the pivot. What is the pivot in all 3 cases? In all 3 cases, what is the pivot? So first you decide your pivot. Come on, hurry up, hurry up, hurry up. Because I want to start the worksheet.
The middle of the crank, the point at which the crank attaches to
Right, the center of the wheel. Yeah, we'll say center of the wheel. Okay, so we will choose those. That's our pivot. Okay. By the way, in this, there can be no other pivot. Okay, that's the only pivot. In beam, you can I mean, while deciding, you can imagine, but in these scenarios, that's the only fulcrum you have. Okay, so that means the perpendicular, this is the pivot, and I want the perpendicular distance to be exactly 0.2 meters, which is the length of the crank, which is only true in this picture. Why isn't it true in this picture? Let's see. This is the pivot, and the line of action is this. Oh, where's my ruler? Okay, can't find it. Okay, so the line of action here. So the line of action of force is passing exactly through the pivot. So what's the distance between the line of action of the force and pivot? 0. 0. So force is 25, but distance is 0. So that means 0. So part 2 is A. Part 2 is A. Part 1 is C. Between now, when the pedal was this way, the turning effect is 0. When the pedal is horizontal, the turning effect is 25. This is in between. So at this position, it was 0. At this position, it is 25. And so at this, so here, what's happening? As the pedal is moving this way, the turning effect is increasing. And this is the maximum. Now, when the pedal will go down, the turning effect will again decrease to 0. Why? Because again, the distance will become 0 between the line of action of force and the pivot. So it's increasing, reaching its maximum value here, and then decreasing again here. So here it will be between 0 and 5. Sorry, not 25. Sorry, 5. Yes, sorry, 5. I hope you guys are not confused. Okay, so 0 here, 5 here, and in between here. So this will be B. Did you understand? Did you guys understand?
Yes, Miss.
Abdul Wadud?
Yes, ma'am, understood.
Okay, good. Let's move on to the worksheet. Okay. Now I will share my screen. Okay, wait. I'm already sharing my screen. Okay, can anybody, we'll have to wait. Okay. Jaldi. We're getting late. We should have done this before. I'm sorry about this. Okay, go in this voluntary science classes. Yes, scroll up. Yes, scroll further up. Yeah, this one. Yeah. Yes, I'm sharing my screen. Okay, can you guys?
No, you're not sharing.
Yeah, I am. New share. No. Yes. Okay, now you can see?
Yes.
Yes, Miss.
Okay, good. Okay, circle the correct option. A uniform rod rests on a pivot at its center. The rod is not attached to the pivot, meaning it's not fixed, it's movable. Forces are then applied to the rod in 4 different ways as shown. The weight of the rod can be ignored. Which diagram shows the rod in equilibrium? So because the rod is uniform, that means the weight is going to be passing through the center of mass, which is going to be the center of the ruler as well, because it's uniform. Okay, so but they have told us to ignore it, so good. And even if they had not told us to ignore it, it was getting canceled out by the pivot, by the upward force of the fulcrum. Okay, which diagram shows the rod in equilibrium? Now, what were the two conditions that we discussed for anything to be in equilibrium? What were the two conditions? Ramin, can you tell me the two conditions for equilibrium? I want
Stable and unstable.
yes, beta, what were the two conditions? One was, I'm giving you a hint. One was that no net moment should act, meaning all clockwise moment is equal to anti-clockwise moment. The other one was all the upward is equal to all the sum of the upward forces is equal to the sum of the downward forces. Okay. So we cannot use that upward and downward one. We cannot use that. The sum of upward forces is equal to the sum of downward. Why? Because they have not shown us the upward force exerted by the fulcrum. So we cannot do that. So we will use the moment turning effect. Clockwise is equal to anti-clockwise. Can you see my mouse moving?
Yes, miss.
Okay, good. So now look at this 100 Newton here on the left-hand side. What moment is it producing? Clockwise or anti-clockwise? This is
Anti-clockwise.
anti-clockwise. This one is
Clockwise.
clockwise. This is clockwise, right? And because it's a uniform ruler, the weight must be at the center, which is being neutralized by this fulcrum. And also the distance should be, and so therefore the fulcrum should be at the center. Okay, therefore the fulcrum should be at the center. Because it is at the center, that means this distance is equal to this distance. Did you understand? So both the forces are equidistant from the pivot. So this is anti-clockwise, this is clockwise. So this looks to me to be in equilibrium. This is in equilibrium. Let's look at this B. What is this doing? What moment is it? This is clockwise. This is,
Isn't it anti-clockwise, miss? No, wait,
Oh,
it's
sorry.
clockwise. It's clockwise. It's clockwise.
yes, this is clockwise. Okay. What is this doing? This is
Anti-clockwise.
anti-clockwise. Okay. So yes, this is yeah, they are canceling out each other, but there is a problem. The fulcrum is exerting an upward force as well. So all the three forces are upwards, and they told us to ignore the weight. Yeah. So yeah, there has to be some downward force to balance this. So there should be some downward force to balance this. So this doesn't seem to be in equilibrium. Okay. C, let's talk about C. This is upward force, so this is a turning moment. So remember, you have to keep both the conditions in mind. Total upward is equal to total downward, and clockwise is equal to anti-clockwise. Now this is clockwise. This force, 100 Newton, is creating what moment? Clockwise.
Clockwise, miss.
Yes, clockwise. Okay. Clockwise, and this is anti-clockwise.
No, it's also.
Yeah, this is also clockwise, right? Yes, so that is why this is not in equilibrium, because both of them are clockwise, and so we don't have anti-clockwise here in this picture, in this C picture. We don't have anti-clockwise, both are clockwise. Did you see? So this cannot be in equilibrium. Cannot be in equilibrium, okay? What about D? Now, first of all, this 100 Newton is canceling out this other 100 Newton. So gone, both are gone, canceled out. So what we are left with is this 100 Newton. And so we have only clockwise moment again here. We don't have anti-clockwise in this. So this is also not in equilibrium. So only A is in equilibrium. Nibita, rod B needs a downward force for
Miss, the
equilibrium.
rod.
Yes.
Miss, the rod would just be lifted off the pivot.
Where?
Wouldn't the rod be just lifted off the pivot? Because if it said that the weight is ignored.
Yes, yes. So that's what I was saying. Yeah, so that's what I was saying. There is no downward force to balance it. Because you see, because another thing, you see, the fulcrum is also exerting an upward force. Remember that, but that is being neutralized by the downward weight, which they told us to be ignored. But it is there, and so forget those two forces. Forget the upward force exerted by the fulcrum and the downward weight, because they are canceling out each other. So they are out of the picture. Yes, Abdul Wadud, you're trying to say something?
Ma'am, so the answer will be C.
No, beta, answer will be A, because they are asking which diagram shows the rod in equilibrium. In equilibrium. So B, C, and D are not in equilibrium. They are unstable. They are not in equilibrium.
Ma'am, this question is of past paper, and my sir solved it, and the answer was C.
How? How was it C? I mean, is that answer from your sir, or is it in the answer key?
Sir, ma'am also in the answer key, and the sir also solved it.
Okay, how did he solve?
Ma'am, he.
Yes, Zainab? You want
Miss,
to?
I'm sorry, but about this same question, I was doing practice of this paper, and the answer was A. It also showed in the marking scheme. And the reason was that because both of these forces cancel each other out.
See, the answer was A, right?
Yes, Miss.
Yes. So yeah. So the thing is that this 100 Newton on the left-hand side is exerting an anti-clockwise moment, and this one is exerting a clockwise moment. Both are same. Both are equal. How do we know that they are equal? Because number one, the forces are equal. Number two, that they are equidistant. There is the same distance from the fulcrum. Now, how am I saying that the distance is the same? Not by looking. Not by looking. Okay, I know that the rod is uniform, so therefore its center of mass is going to be the center of mass is going to be at the center, and the weight has to act through the center, and the fulcrum has to neutralize that weight for this rod to be in equilibrium. Therefore, I know that the fulcrum is exactly at the middle point. Did you understand?
Yes,
are you convinced? Yes, Abdul Wadud, do you have any question? How is it C? C, Abdul Wadud, look at, let's solve this together. Okay, again, once more. I just did it, but I'll do it once more with you. Look at this, forget everything else. Just look at the pivot and this force. In what direction is it causing a turning effect? This is
clockwise.
Clockwise. So this is clockwise moment, okay? Equidistant, same magnitude, so no problem there. Okay, we will only look at the direction. Now look at this force. Forget this one now. Look at the pivot and this force. In which direction is it producing a turning effect? This is going this way.
And it will
Clockwise.
Yes.
So this is clockwise and this is clockwise. So the rod will turn because there is no anti-clockwise moment to neutralize it.
So Miss, it'll start moving like a circle.
Exactly. Yes, Zainab, very good. Yes.
Oh,
okay, let's move on.
I'm sorry, it was wrong. My bad, sorry.
No, that's fine. That's fine. But you understood, right? It's okay. Okay, question number 2. The diagram shows an object moving at a constant speed in a circular path in the direction shown. A force acts on the object to keep it in the circular path. In which labeled direction does this force act when the object is in the position shown? I think we have done these sort of questions easy peasy. Who's going to answer? Somebody other than Zainab and Rami?
B.
Okay, yes, very good. Why? Just in one sentence, answer me. Short sentence. Yes. Remember, there's an force is equal to mass into acceleration. Newton's second law of motion. So acceleration is towards the center of the circle, and so the force will also be towards the center of the circle. Okay, question number 3. A car moves in a circular path as it turns a corner on a horizontal road. The car moves at constant speed. Which description of the forces acting on the car is correct? First of all the forces are balanced. If all the forces are balanced, then that means there is no net force. And if there is no net force, then how come the car is accelerating, meaning going in a circle? Because going in a circle means changing direction constantly, which is acceleration. So there would be no acceleration. There would be no circular path. This A is outright wrong. Okay, move on. The forces are unbalanced. Yes, they are. And the resultant force acts away from the center of the circle. So that's wrong. Okay. Forces are unbalanced and the resultant force acts towards the center of the circle. The forces are unbalanced and the resultant force is in the direction of travel of the car. So which one? Ramin?
It's C.
C. Yes, perfect. It's C. Okay, question number 4. Good job, Ramin. A uniform rod XY of weight 2 Newton has a length of 80 centimeters. The rod is suspended by a thread 20 centimeters from end X. A weight of 5 Newton is suspended from end X. Okay, a student hangs a 6 Newton weight on the rod so that it is in equilibrium. What is the distance of the 6 Newton weight from end X? So it is one of those questions that I was talking about. A lot of forces acting, right? So has anybody solved this? Has anybody done this already?
1 second, miss.
Sorry?
Just 1 second.
Oh, you're trying to solve it?
Yeah.
Okay. Okay, I am sharing my camera. Oh, sorry. Okay. Okay, so I reproduced this diagram. Okay, here. Now, first of all, there is some 6 Newton weight, the distance of which we don't know. Okay, but it is somewhere here, and we know that it's downward. We know that, right? 6 Newton acting downward, hanging. They use the word hanging. I cannot show you the question again. If you have the question in front of you, read it. It's saying 6 Newton is hanging. Okay, so hanging meaning downward, right? So it must be whatever the distance, it is downward. Why is it important to know downward? Because when we will choose a pivot, downward and upward will help us decide if it's moving the beam clockwise or anti-clockwise. So let's choose our pivot. I am choosing point X. Well, you can choose point Y as well. You can, and you will get the same answer, but I'm choosing X, okay? So, first of all, I am also, because you know how many forces are in total, how many forces are acting on the beam? 1, 2, 3, okay? And also the 6 Newton one, fourth. That 6 Newton one, which I don't know, but I'm just making it like that so that I don't forget it. So 1, 2, 3, and 4 forces. Okay, I'm ignoring the weight. Okay, forget the weight. Okay, so taking moments about X. Now, if I'm taking the moment about X, I will cancel this force. Why? Why will I cancel this force? Anybody knows? I mean, in my calculation, canceling meaning for my calculation, I will not consider this force. This will still be there in the question, but not in my calculation. Why? Does anybody know?
Can I answer, miss?
Yes, Zainab, yes.
If we take X as a pivot, that means we have to imagine that there would be a pivot under X, which would cancel the 5 Newton force so that it's a pivot which will move.
Well, that's good thinking. Very good. Yes. And also think this way, that turning this has zero turning moment, because remember it's passing through X, so distance is zero. So turning moment of any force is the product of its magnitude and the distance. So distance is zero. So zero turning effect, no turning effect. So forget it. Okay, because turning effect is zero because it is passing through the pivot. Remember the formula for turning moment was force multiplied by the perpendicular distance between the line of action of force and the pivot. So that's
Miss,
why. Yes,
Miss, I cannot understand it.
Is that Rami?
Yes.
Okay. Where did you understand? You understood that I am saying that 6 Newton is acting downwards. Did you understand that? And I have to find out where the distance, it might be here, it might be somewhere here, I don't know, but I just wrote it down here. I know there are 3 downward forces, 5 Newton, 2 Newton, 6 Newton, and there's only one upward force. Okay, we are ignoring the weight. Why? Because maybe did they mention in the question to ignore the weight? Yeah, I don't remember, but or maybe 2 Newton is the weight. Is 2 Newton the weight? I cannot, share 2 screens at this moment, and I have that worksheet there. So maybe this is the weight. Read the question. बेटा एक मिनट, ये है ना, ये वाला. You guys don't even tell me the question. Yes, a uniform rod XY of weight 2 Newton has a length of 80 centimeters. Weight 2 Newton. Sorry, this is the weight. Okay, Rami, now it is going to be even clearer. This is the weight. Okay, so I was getting confused. Okay, so now we have how many forces? 1, 2, 3, 4. Okay, Rami. Now, I will choose a pivot. Okay, any pivot. You can choose any point. For now, I am choosing X as my pivot. Now you might have this question, what if I choose this thread as the pivot? Or what if I choose this center of mass as the pivot? Or what if I choose Y as the pivot? Yes, you can choose any of them. You will get the same answer. I can show you the working with different pivots, and I can show you that the answer can be right. Answer is correct. If you want me to do that, I can. But for now, and please mute yourself, but for now I'm taking point X. So be with me. I'm choosing point X as my pivot. Now I will take each force one by one. 5, okay. Don't ignore 5. Okay, Ramin, if that's confusing you, don't ignore. Consider it. But tell me something. What will be its turning effect? 5 multiplied by its perpendicular distance, right? So what's the perpendicular distance? 0. It's passing through X, right? Rami?
Yes.
Right. So it's 0. So it doesn't matter. Okay. Canceling meaning multiplying by 0. That's why I'm canceling it, because the distance is 0. So how can you say if it is clockwise or anti-clockwise? You cannot say. See, for example, this is my beam. This is my pivot. Pivot is that point which is not allowed to move. Not allowed to move, even if the force is being applied. So if I apply force 5 Newton with my finger, it's not moving. There is no turning effect. Okay, because the distance, there is no distance. It is passing through the point. So there is no turning effect. Okay, did you understand this point? Now, let's move on. This force. Okay, how did I get this force? I use that law of moment, that total downward force is equal to the total upward force. So I didn't know the upward force, but I knew the downward forces. I added all of them up. I also added 6 Newton, because though I don't know the distance of 6 Newton, I know it is downward and I know its magnitude, it's 6. So I can add them up. 6 plus 5 is 11, plus 2 is 13. 13 Newton. So, according to the law of equilibrium, total upward forces is equal to total downward forces. So this must be 13 Newton. Okay, so now using that law of moment, taking moments about x, clockwise moment. So 13, what is 13 doing? Moving clockwise or anti-clockwise? This is anti-clockwise. So I wrote down 13 multiplied by the distance, the perpendicular distance. The perpendicular distance is 20 centimeters. So 13 multiplied by 20. Now, next force here, there's 2 Newton. Please mute yourself.
Hyundai Bukhari.
Who is this? I Bukhari. Okay, maybe this is me. Sorry. Okay. Okay, so this is this force. Okay, what is this force doing? Moving it clockwise or anti-clockwise? Clockwise, right? So 2 multiplied by what distance? 40. So clockwise moment, 2 multiplied by 40. Now, next force, 6 Newton. Now, I don't know where this 6 Newton is, but wherever it is also moving it this way, right? So this is also clockwise. So I multiplied 6 by its unknown distance. I don't know the distance, so I gave it an x, okay? So is there any other force left? No, I included all of them, okay, except for this. So now I have this equation. Now I'm going to solve it algebraically. And so my x is 30 centimeters. So 30 centimeters meaning, now my diagram is not exact, but 30 centimeters seems like here, somewhere here. So 6 Newton would be acting here. Okay, Ramin? So 30 centimeters is the answer for this question. Okay, okay, next question. What is the next question? Can you take this out here? You guys have the worksheet with you, or should I share?
Ma'am, you
Miss,
can share, it's better. I don't have it.
You don't have it? Okay. Okay, okay.
Ma'am, you can share 2 screens at a time, 2 tabs by clicking control.
By clicking what?
Control. Control and select those 2 tabs.
Advanced. क्या advanced में जाके करना? Breakout rooms and meeting. Okay, okay, I'll work this out later. Right now, because I don't know, I'm not familiar with it. So let me just. Okay, question number 5. A wooden plank rests in equilibrium on 2 rocks on opposite sides of a narrow stream. 3 forces P, Q, and R act on the plank. How are the sizes of the forces related? Easy peasy. Abdul Wadud. Yes.
Ma'am, P plus R is equal to Q.
Okay, how? Which law are you applying here?
Ma'am,
Which? Yes, Rita. Total upward forces is equal to total downward forces. Okay.
yes.
Yeah, total upward forces is equal to total downward forces. Okay, Ramin? Okay, question number 6. 3 children X, Y, and Z are using a seesaw to compare their weights. Which line in the table shows the correct order of the children's weight? Now we will assume that these seesaws are uniform rods, okay, and the children are sitting same distance from the fulcrum. Okay, all these are assumptions. So which line in the table shows the correct order of the children's weight? So by looking at the pictures, we know, looking at these 2 pictures, if you follow my mouse, we know that Y is heavier than both X and Z. Okay, Y is heavier than both X and Z. So that means that Y is the heaviest. So either C or D. So, okay, now the question lies, The question remains about X and Z. Which one? So that means Z, looking at this picture, we know that Z is lighter than X. So that means Z is the lightest, right? So Z is lightest. So C is the option, according to me. Yes, Abdul Wadud? Yes, you want to say something?
I was gonna give the answer.
Okay. Let's do question number 7. It is similar sort of a question. The weights of 4 objects, 1 to 4, are compared using a balance. Which object is the lightest? Somebody wants to answer? Saima. Who said B? B, object 2, you mean. See, we know that 2 is lighter than 1, okay? And we know that 2 is lighter than 3, okay? I also want to show you so I am, writing down the numbers in the order, okay? So I know that 2 is lighter than 1, and 2 is also lighter than 3. I don't know how I have to share this.
Answer is D, object 4.
Yes, our answer is D, object 4, but I want to show them the working. Can you make out the working, or you want me to?
I'm sorry, miss, I don't understand. Could you explain?
You didn't understand?
No.
Okay. Okay. No, but I cannot, since I cannot
Oh,
share.
wait. Oh, can I, if I try explaining, would you correct me?
Yes, sure. Yes,
Oh,
sure.
for 2, for object number 2, it's lighter than 1 and 3. So in the first 2, object 2 is lightest. But then when you come to the third one, object 2 is heavier than 4, which would mean that 4 is lightest.
Okay. Can you see this?
Yes,
I'm
miss.
trying. Okay, okay. So according to this, I am now, trying to start page 3. Minute. Okay. So I am writing it this way. So 2 is, what did they
Ma'am, your
ask?
voice is so low.
यार उसको कैसे लिखना चाहिए? Okay. 2 and 1. So 1 is heavier than 2. 1 is heavier than 2. Then 3 is heavier than 2. And 1 is also heavier than 2. Okay, 1 is heavier than 2, and 3 is heavier than 2. And then 2 is heavier than 4. Okay. So there are only 3 pictures, right? Okay. So now we have to arrange them this way. So 1 is 1. Oh, I don't know how to explain this right now. I did it myself, but I don't know how to explain. Okay, there's difference between understanding yourself and explaining somebody. Let's leave this for the end, okay? Let's leave this for the end, because then, otherwise I will lose time for the rest of the questions. I don't know how to, let me come up with some way to explain you. Okay, let's just move on. We are already running out of time. Okay, question number 8. A piece of cord has its center of mass at M. Which diagram shows how it hangs when suspended by a thread? Does anybody want to answer and explain? Muaz? Some new participants? Ramin? Yes. Come on, people. Yes, Zainab?
It would be Amos, because this
Yes.
because like from the point like they would, let's imagine like a line through the point, and that line should pass through the center of mass.
Right.
if it was suspended by the thread. And like in
Right.
A, it's going directly through M. In B, it's slightly away from M to the left. C, it's
Yes.
out of the card, and D, it's also out of the card.
Right. Right. Now I am again sharing my camera here. Okay. See, when you have anything hanging, when you have anything hanging, there are two forces acting on it. One is its own force, and the other is the upward equal and opposite reaction on the support, wherever it is getting its support, right? Now, if they are passing through the same line, they are equal and opposite, so they will cancel out each other. If they are equal and opposite, they will cancel out each other. Okay, but if they have different lines of actions, like in this picture, if they have different lines of actions, instead of canceling out each other, they will form each one will have a turning effect. Each one will have a turning effect, and so as a result, the thing will tilt, or the thing will, it will tilt till the upward force comes in the same line as the weight. You understand? So if, in this picture, this is a piece of paper, a hexagonal piece of paper, and the person is lifting it this way. But when he leaves it, what happens? The weight has a turning effect about this pivot, and so this paper comes back to its original position. Original meaning that the line of support is exactly the same as the weight, like this picture, in this picture. So here they cancel out each other, so no net force acting on this, and so now it is in equilibrium. Okay, so this is how we find out the center of mass of any object. How we make it hang. We hang it, and then we draw a perpendicular line, because that perpendicular line will represent the line of action of that force. And we will hang this paper at different points, and each time, no matter, irrespective of what point you hang it from, the line of action of the support will exactly will pass through the center of mass. Why? Because it has to balance the weight, and the weight is passing through the center of mass. I hope I made some sense. Okay, now look at this. I don't know if I can show you this. Can you see the diagram?
Yes.
Yes, miss.
I cannot. Okay, look at this. So wherever the object is resting, at that point, there is an equal and opposite force, upward force exerted by that support on that object, right? So why does anything fall? See, here it's stable. Why? Because the upward force is being canceled out by the weight. So this is a stable position. Here it is in equilibrium. But here, can you see their lines of actions are different? As soon as their lines of actions get different, it topples, because they exert a turning effect, so it topples. So in all these three examples, the object will topple. Why? Because their lines of actions are not the same, they are different, and so they are exerting a turning effect. Wherever they have a turning effect, they will exert their turning effect and the object will topple. Okay, so keeping this in mind, let's move on to the next questions. So only in A is the support, the line of support, the same as the weight. The line of action of the support is falling. The weight is falling on the line of action of the support. Question number 9. A simple balance has two pans suspended from the ends of arms of equal length. When it is balanced, the pointer is at 0. 4 masses in total are placed on the pans, with one or more on pan X and the rest on pan Y. Which combination of masses can be used to balance the pans? Yes. Yes, Abdul Wadud, Muaz, Ramin, Saima.
It's B.
Ma'am, yes, it's B, I think so.
How come? Yes, it is B, but explain how.
Because if we place 5 gram on pan X and the remaining 3 on pan Y, it will be 5 gram, which will be B.
Right, right. So 5, 5. Okay, so I think you guys know this. Let's move on. If anybody wants me to explain, then you can ask. Okay, question number 2. Two forces act on an object. In which situation is it impossible for the object to be in equilibrium? Number 1, the two forces act in the same direction. Yes, because there has to be some force to balance them. If both the forces are acting at the same direction, there will be nothing to balance them, right? So no matter what the size of the two forces is, whether they are small in magnitude or big in magnitude, but if they are in the same direction and they don't have any other force canceling them out, then that means they are acting. The object cannot be in equilibrium. Equilibrium means no net force. Remember this, no net turning effect. If there is turning effect, that means the object is not in equilibrium. If there is some force acting on it, that means the object is not in equilibrium. Okay, do you get me? Option B, the two forces act through the same point. Now, the two forces might act through the same point and cancel out each other, and so the object will be in equilibrium. So point B is wrong. Point C, the two forces are of the same type. So even if they are of the same type, the object can be in equilibrium. Okay, if they are in the opposite direction. The two forces are the same size. Yes, if they are the same size, provided they are in the same in the opposite direction, they can cancel out each other and the object can be in equilibrium. So it is only option A in which the object cannot be in equilibrium. Okay, only in option A the object cannot be in equilibrium. Okay, question number 11. The diagram shows 4 models of buses placed on different ramps. How many of these models will fall over? Whoever answers will also tell me in short why he or she chose that answer. Zainab is the only one answering. Muaz? Yes, Abdul Wadud?
Ma'am, it will be option D.
Okay, explain.
Ma'am,
Yes.
because center of mass is tilted and the bus will fall over.
The center of mass is tilted. Okay, then what about the third picture?
Ma'am, the center of mass is less tilted than option D.
Okay, also pay attention to the question. They asked how many of these models will fall over? How many? So what did you say? You said D.
I did
What was
not see that. I did not see that. It will be then option B.
2?
Yes, the two will fall over.
Picture number 2 or 2 more models will fall over?
Two models will fall over. Picture
Which
number
ones?
and 4.
Okay, when you said the center of mass is tilted in the last 2, in the right 2.
Yes.
These 2 pictures, right?
Yes.
So what about this? Here it's tilted here as well, here and here. Though less, but they are tilted.
It's less, so I think it will not fall over.
बेटा thinking पे नहीं होता physics में. Okay, you have to explain me in detail. Why do you think? What makes you think that way? Yes, think. Give me a good answer, convincing. I'll give you a hint. It has to do with turning effect. It has to do with the lines of actions passing through each other. When the lines of action will pass, I'm giving you hints. Okay, Zainab?
Miss, I think it would be A, because
Yeah.
for an object to tilt, the line of action should pass outside its base.
Outside its base. Very good.
Base. So for 1 and 2, it's definitely inside. For 3, I actually took its printout, and for 3, it's still inside the base. It's very slight,
Very
but
good.
it's still inside. For
Very
4,
good.
it's visible that it's going outside the base. So answer would
Very
be A.
good. Yes. I like your answer. Yes, but I will explain this a little further. I'm sharing my camera because I will have to make a diagram. See, when you are looking at this diagram, this is the bus. Okay, these are the wheels. Okay, this is, sorry. Okay. Okay. Now, this is the center of mass, for example. Now, how will you decide if it will tilt or not? For that, if, for example, this is the horizontal. Now, this is the weight. This is the weight. Okay, look at the line of action of weight. What is base? Base is from here. This is base. Okay, Zainab, you will not take this as the base. You will not take, what I'm trying to say is that don't take this whole thing as the base. From the wheels, from where it is resting on the ground, this is base. This is the base. Okay.
Oh, okay, Miss.
Yes. Okay. Remember this. If, for example, the truck is this big, the truck can be this big, but still the base is this. This is the base. How will you decide on the base? Like, you know, the two supporting points on the ground, they will decide the base. In fact, it can even be, you know, the touching point, to be precise, touching point. This is the base. This, where you see the touching, the contact between the ground and that is the base. Now, why is it important for the weight to pass through the base? Because this whole base is providing an upward and opposite reaction force onto this bus, this way, an upward and opposite reaction force by this ramp on the bus, which is perpendicular to the horizontal. This is trying to balance the weight. So when, can you see their lines of actions are different? And this line of action, as long as this line of action of weight is outside the base, this weight will have a turning effect. This contact is acting as a pivot. So about that pivot, about this fulcrum, this weight is going to have a turning effect and the bus will topple because it's not in equilibrium. There is no other force or turning effect of any force which is counteracting it, which is canceling it out. So this is unbalanced and therefore this weight will exert, you can say, a clockwise moment on the bus and will cause it to topple this side. Okay, in the rest of the pictures, the tilt was not that much. So tilt was not that much. And so the weight was still falling through the base. You understand? So here the tilt was not that much. So the weight was still passing through the base. So it was getting canceled by the upward force exerted by the ramp. And so there was no turning effect because they were canceling out each other because they had the same line of action. They had the same line of action, and so they were canceling out each other. Ramin, did you understand? If you didn't understand, I'll repeat.
Oh, I understood.
Okay, good, good. So remember the factors whichever factor will cause the line of action of weight to fall out of the base, all those factors will cause instability, such as hiring of the center of mass, hiring of and how can you hire the center of mass? If you have, if for example, some trucks, big luggage load on them, their center of mass is higher. It's higher because can you see it's not symmetrical? There is more mass on the upper half of the object. So the center of mass will be higher. So this, charge this laptop. Charge this laptop. Yeah, it's getting charged. It's getting charged. So if the center of mass is higher, the more likely the line of action of weight may be out of the base. It will be more likely for the line of action of the weight to be out of the base. Did you understand? Okay. Let's move on to next question. I'm trying my best to finish this worksheet. I know I'm out of time. Question number 12, a light aircraft stands at rest on the ground. It stands on 3 wheels, 1 at the front and 2 further back. Which point could be its center of mass? Yes.
It's A. I think it's A.
C? Is that what you're saying?
I'm saying A.
Oh, Ramin, you're saying A. Okay, what makes you say A? Yes, please explain. I think it should be B. I think it should be.
It is B, miss.
Yes, ma'am, it's B.
Yeah, why?
Ma'am, because if we draw the lines and find out the center of mass, the lines that in the middle, it will only come at B.
I mean, you're hanging the helicopter and then, and then you're deciding. I
Yes,
mean,
ma'am, that's another way that our cell told us to find out the center of mass.
okay. Now, the thing is that hanging method is only applicable for flat surfaces. Okay. For flat surfaces, that will work. But if you have 3-dimensional objects, like such as this helicopter, you have to see where is the bulk of the mass. Where is the bulk of the mass? First of all, that's one point. Secondly, they also gave some hint here. 1 at the front, there's only 1 wheel at the front and 2 further back, meaning I can see these wheels are bigger and there are 2 of them and there's only 1 at the front. This also shows that there is more support required here to counteract the weight. And weight must be at the center of mass. I mean, weight acts through the center of mass. So in order to balance it out, they are providing upward, opposite, equal and opposite force by keeping the supports here. So that the support, which will be the upward and opposite force exerted by the ground, will nullify or balance the downward weight. And because the bulk of the mass of helicopter is here, can you see these are small extensions only. The bulk of the mass is here at the center. So most probably the center of mass is going to be somewhere in this region. Somewhere in this region. Okay, so this is what my understanding is. Did you understand? Did you guys understand?
Yes,
Yes,
miss.
ma'am.
Okay, question number 13. The diagram shows 4 objects standing on a flat surface. The center of mass of each object is marked M. Which object will fall over? Now, again, in all these 4 objects, what you will do is you will draw a downward line through this point marked M, and you will see if it is passing through its base. And that line should be perpendicular to this horizontal line. If it is passing through the base, then that means the object is stable. It will not fall. And if it is passing outside the base, then it will fall. So without drawing lines mentally, just by looking at these 4 pictures, tell me. Ramin, you tell me.
C.
C, very good. Good job. C. Okay, because can you see the base is on the left side? And so you can easily see that the line of action of the weight will fall outside the base. Question number 14. The diagram shows a balance being used to find the weight of a baby. The weight of the basket can be ignored. At equilibrium, the pivot is nearer to the weight W than to the baby. What is the weight of the baby? Less than W, more than W, W, or impossible to tell? Yes, Zainab?
It would be less than W, miss, because you explained before that if distance is bigger, then
Very
that
good.
means the mass would be less. And
Yes.
if distance is smaller, then mass is more.
Yes. So to have the same, because this beam is balanced, that means that both the turning effects are equal and opposite, first of all. So to be equal and opposite means that if the distance with W is less and distance with the baby is more, I mean, between the baby and the pivot is more than between W and pivot, then that means the force exerted by the baby must be smaller. Smaller, because the distance is greater. Ramin, did you understand?
Yes.
Okay, are these really IGCSE questions?
Yes,
Yes,
miss.
ma'am.
They're from the past papers.
Okay, because they don't
I
usually
will.
give an option like impossible to tell.
Miss, I think that's a hint for us. Then there's no way it could be D.
You know what? They don't give hints this way. You know, the quality of questions has gone down a lot. Each year I observe this. Okay, anyways, question number 15. Passengers are not allowed to stand on the upper deck of the double-decker buses. Why is this? Okay, let's read the options first. Let's read the options first, and then I'll give you a chance. They would cause the bus to become less stable. They would cause the bus to slow down. They would increase the kinetic energy of the bus. They would lower the center of mass of the bus. Okay, Abdul Wadud.
Ma'am, they would cause the bus to become less stable.
Okay, how?
Ma'am, because if they stand, they would change the center of the mass, and it can
How will they change? How will they change it? What will, I mean, will it go higher, lower, sideways?
It could go higher.
Very good. And so, if it goes
And
higher,
so
what happens?
the bus becomes unstable.
Okay, Zainab, you want to add? When the center of mass goes higher, what happens?
If the center of mass gets raised, so then the bus gets more unstable. And then...
Yeah, that's my question. Why?
Because it would be, miss, could it be easier for the line of action to come a bit out of the base,
Yes.
nearer to the, then lower to the base, like nearer to the base?
Yes, yes. That's exactly I wanted you to say. As the center of mass goes higher, the line of action of weight, it's more likely to get out of the base. The higher the mass, the center of mass, the more likely the line of action of weight to get out of the base. Do you understand this? Did you understand this? See, the lower the center of mass, the more you will have to tilt for that line of action of weight to get out of the base. And the higher the center of mass, the less tilting you will have to do to get the weight, the line of action of weight to get out of the base. Okay, if something is tall, even a slight tap will cause it to topple. If something is tall and thin, something is tall and narrow, and it has a narrow base. So anything that hires the center of mass, anything that narrows the base will make the object less stable. Okay, remember this, because it's all about the line of action of weight getting out of the base. Ramin, are you with me? Okay, question number 16. The diagram shows a force being applied to a lever to lift a heavy weight. Which change would enable the heavy weight to be lifted with a smaller force? A, move the force to the right, move the heavy weight to the right, move the force to the left, move the pivot to the left. Ramin? Ramin, beta, I want you to answer this. Which change would enable the heavy weight to be lifted with a smaller force?
Can I tell?
Ramin, can you answer this? It's okay if you get wrong. It's okay. We'll think it together.
Move the force to the left.
Yes. Why did you say that? What's the reason? Yes, you are correct. Because?
Because if the distance is small from the fire.
Yes. So when you move the force to the left, you are increasing the distance, the perpendicular distance between the line of action of the force and the pivot. So you are increasing the turning effect. You are increasing the moment. Now, if we consider the other options, move the force to the right, doing that would decrease the distance. If we move the heavy weight to the right, you are further increasing this turning effect, which you want to balance. So that's not the answer. Then move the pivot to the left. If you move the pivot to the left, again, you are decreasing the distance between force and pivot. So that will decrease the moment, okay? Okay, question number 17. A plane lamina with center of mass X touches the ground at point P. Which diagram shows the lamina in equilibrium? Okay, also pay attention to the word lamina. What is a lamina? A thin sheet, thin layer is called a lamina. Thin layer is called a lamina. So remember, this method is good for thin plain sheets, okay? Or anything which is flat or, you know, like a thin sheet. Which diagram shows the lamina in equilibrium? Yes. Okay, Abdul Wadud. Yes, Abdul Wadud. Can you unmute yourself? Okay, Zainab.
Yes, ma'am, it will be point B.
Yes, why? Because?
Ma'am, because the center of mass is in line with the point, with the base.
Right. So the upward force is balancing and canceling. Okay. A wooden bar is pivoted at its center so that it can rotate freely. Two equal forces F are applied to the bar. In which diagram is the turning effect greatest? Yes, it is.
A, miss?
Sorry?
A.
Yes, it is A, because both the forces are clockwise. Okay, if you look at both these forces, they are both clockwise and they are at their maximum distance from the pivot. Now here, this force is at the maximum distance, but they both are also providing the same clockwise, but the other force is not at the maximum distance. Okay, this one is not at the maximum distance. So therefore, this is the maximum, has the greatest turning effect. Okay, Ramin, did you understand? Okay, question number 19. This is easy. Which labeled, I'm not reading the whole question. Which labeled arrow shows the direction of the resultant force on the, so it's D, okay, towards the center of the circle. Let's move on. Question number 20. The diagram showed 3 uniform beams, P, Q, and R, each pivoted at its center. The 2 forces acting on each beam are also shown. Which beams rotate clockwise? Okay, so clockwise will be these. Okay, if the fulcrum is at the same place, there are only 2 forces. Both of them are acting downwards in all the 3 cases. So we know that this on the right-hand side is clockwise, and on the left-hand side, this is anti-clockwise. So which beam will rotate clockwise? Whichever will have a greater clockwise moment. So let's look at this. Clockwise is 4. 4 multiplied by 1 is 4. Anti-clockwise is 8. So this will, 8 is greater than 4. So this will rotate anti-clockwise, not clockwise. Okay, are you guys with me? So P is definitely wrong. Look at this beam Q. Clockwise is 5 multiplied by 2, 10. And this is anti-clockwise is 2 multiplied by 4 is 8. 10 is greater than 8. So Q will rotate clockwise. Again, R. 1 multiplied by 4 is clockwise, and 1.5 multiplied by 2 is 3. So 4 is greater than 3. So clockwise movement. Yeah, so I'm doing it real fast. Okay, so clockwise moments in case of Q and R are greater than the anti-clockwise moment. So Q and R will rotate and clockwise. Okay, Q and R. Option C is the correct option. Is there any question?
No, ma'am.
Ramin, did you understand the last question? I did it really quick.
Yes, I understood.
Okay. Okay. So do you guys want me to do the other worksheet? I mean, in the next class, or I was thinking I will just make a video and post it for you guys.
Ma'am, our paper will be on Sunday of physics.
Yeah. So just tell me, do you find the other worksheet hard? Do you want help with that, or you guys are okay with it? If you will request, only then I will solve it. Otherwise, then this will be it. Okay, you guys are not answering me, so I will take it as that you guys don't want it. Okay,
Okay, ma'am.
Rami, do you want? Okay then. Okay, assalamu alaikum wa rahmatullahi wa barakatuh.
Walaikum assalam.